So now to get to our specific display that we're putting together this year, I wanted the lightning effect. So I bought these two LED floodlights, less than $19 for the two on Amazon, 50 watts each, and ran extension cords from them over to two of the outlets on the control box. Fortunately, even though these are LEDs, somehow they do not blink when I plug them into the solid state relays, so I did not have to rewire those as well. Rather than mounting the floodlights onto the side of the house, I went ahead and just mounted them to these two scrap pieces of 2x4 and then clamped those onto the edge of the roof so that the floodlights shone down and would light up a nice region of the side of the porch. My animated skull goes into the closet. It's sitting on top of a speaker, one of the two speakers of our stereo system, and also a box just to get it up high enough. And I use some old black felt to make a drape around it to look like a shroud and cover up all of the non-essential bits. I thought about covering up all the pipes in the background, but doing that from outside the closet rather than inside was a little bit of a challenge, so I decided to just do it this way. I mounted a 12 volt 150 kilogram centimeter servo inside the doorway with some scrap metal that I used to make the connector to connect it to the door and control it. There are a couple of caveats to watch out for when using a servo like this to move the door. The way this particular one is mounted right here, the outside screw on the door is actually into very thin wood because it's a hollow core door. And so it actually can pull out of the door quite easily. A couple of solutions to that is move the whole system up so that you're near the top of the door and your screws are into solid wood then. An alternative is to put an extra piece of wood across the inside of the door. This is what I did, screw it in on both ends, and then these screws on the metal bracket actually go into that additional wood. That worked quite well. Another problem is that this servo, 150 kilogram centimeter servo, pretty much keeps the door shut if it's powered up. You cannot open it without breaking something. And so rather than trying to work out little pin connections that I could pull out or something like that, I put the power outside, the control box outside, with a power strip powering everything, and then I can just turn it off quite easily, depower the servo, and open the door. The skull contains a servo for operating the jaw, as well as two LEDs, one in each eye socket. Our skull has one PWM output wire cable for the servo and two cables coming out, one for each of the eyes. To attach the servo cable, you just take another cable, PWM extension cable. I bought some 3-foot long ones so that I could string them together because I never have everything next to each other. Attach them together and run this over and attach it to your box. Do this. Now what I've done with the LEDs is I've taken the two separate leads, each of which has one white positive and a black negative. I wired the two white ones together to the white cable on a cut-off piece of a PWM connector. And I connected the red and black lines through the two 220 ohm resistors separately to each of the two black leads. So when I plug this into my system, I'll put plus 5 volts on the white cable, and I'll attach my red and black lines to pins. When those go low, you get a current through the LED and it lights up. When it's high, it does not light up. The servo for the door, as I mentioned, is 12 volts, 150 kilogram centimeters, and it's got the same kind of PWM cable as the servo in the skull. So we'll hook it up the same way, take our cable, plug it together, and the other end goes into our box. I took advantage of the 3-foot long PWM cables I used for this because my skull and door servo are inside the closet, but I want all my hardware, other controls and things like that outside. I needed to run them through a vent to get into the closet. But you can take these PWM cables and simply string them together until you get a 10-foot long piece like this, which was long enough to reach all the way outside to my controls. To attach our servos to our boards in the box, we're going to use our servo breakout board over here. This side's wired up for 5 volts, so we'll use it for the 5 volt servos. This side's wired up to 12 volts, we use it for the 12 volt servos. Now, the servo for the jaw is going to be a 5 volt servo, so we will attach our 5 volt cable to a set of pins on that side of the breakout board. And we attach the cable for our 12 volt servo that's going to open and close the door. We'll attach over on this side. Now, as I mentioned, I wired the LEDs for the eyes together such that it was on a 3-pin cable. And I'm going to attach my PWM 3-pin cable right here on this digital breakout spot. That pin right there, corner one on the far left, is 5 volts. I'm going to attach that to the white wire, and the other 2 pins then, which are D's 9 and 11, I think, will be attached to our 2 LEDs. Again, those pins go low, the LEDs go on. To actually attach my pigtail that's designed to interface to our motion sensor, this pigtail right here has a resistor and a transistor in it. It's got 3 leads that go out to the sensor itself, and then the other end has 4 leads. Red wire goes to +5 here on this breakout connections right here on these pins. Ground goes to ground, and then the green wire goes to the anode, which is your input to the opto-isolator, and the white lead goes to the cathode of the opto-isolator and back into the pigtail. So that's how you wire your pigtail up, and then we'll just run a 3-wire connector all the way out to our motion sensor.
This is our Hauntomator setup for our current set of animatronics for this Halloween. All our audio is up here. We've got 2 servos, one controlling the door that slowly creaks open, stays open for a while, and then slams shut, with a couple little things over here to wiggle the door and scare anybody next to it. We have the jaw on the skull, opens, screams, and closes. And then we have our lighting channels down here, the digital channels. We turn the LEDs on here while the skull is screaming. Those are the eyes.
We turn off the overhead lights here while all of the action is happening, and all our lightning's right in here. Let's take a closer look at that. And we can see that the lightning is on for about 1/4 of a second, and then it goes off and flashes a couple more times. And that's our entire animation. Of course, once you've got all the hardware working, you can use Hontomator to create as many different animations as you like, including of the skull talking, saying words, or doing other actions.
Yes, children, there are monsters in your closet.
And finally, all of that testing and iteration and construction finally resulted in this. Okay, here we are on Halloween, walking up the front porch. Da 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 da, everything looks nice. La 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 la.